Hola, mi clase! We're doing 12.3, last section of Module 12, distance between 2 points. So we're going to use the Pythagorean theorem to find the distance between 2 points on a coordinate grid. We kind of looked at that on 12.2 when we were trying to prove if two triangles, remember that last problem on your 12.2 notes? So it's going to be similar to that. There's no key terms because everything we're talking about today we've talked about. So, right, we've talked about the Pythagorean theorem. We know what a coordinate grid is, so there's no new vocab for today, so that's kind of nice. So I know your guys' graphs are a little faded, okay? So if you need to draw in some lines or some better tick marks, you can. So it says use the figure, the figure shows a right triangle, approximate the length of the hypotenuse to the nearest tenth using your calculator. So it says find the length of each leg. So the example's already been done for you, but I'm gonna explain how they did that. So all they did is it's similar to that graph paper, grid paper problem we did in 11.2. All we're doing is counting how many boxes they're apart. So we just go 1, 2, and so that's how they got that this was 2. So we could say A equals 2, right? Oh, they even switched it. Hold on, they said it down below. I don't want to get us confused. Oh, what am I doing? Here we go. Here, we'll just do this. 2 units. Okay, that way we're not confused. 2. And then all they did was count here. So 1, 2, 3, 4. That's how they got 4 units. So it's similar to that grid paper one where I was crossing off all the boxes. It's very similar, except we're just counting the boxes. So down below they put A equals 4 and B equals 2, and then they want us to find out what C is. And it does kind of tell us we're going to be approximating. I know I just drew all over that. And we're going to do it to the nearest tenth. That wasn't helpful at all because I just drew all over the words. But we are approximating, which means we're going to need to round, and we're going to do it to the nearest tenth, which we have done when it came to square rooting. There we go. I'm just going to circle both of them. So we're going to go 4 squared plus b squared, 2 squared equals c squared. So 16 plus 4 equals c squared. So we get 20 equals c squared. Inverse of squaring is square rooting. So this is where your calculator comes in handy. Okay, if you need to borrow a calculator for this unit, please let me know. And we would get 4.47. I'm going to stop there about, but it does say round to the nearest tenth, so that's why I saved the 7, and I need to bounce this up, so we would say 4.5 about 4.5 units. So this would be our final answer for the length between these 2 points. And that's it. So it's a little bit of it's mainly part 12.1, but it's just combining it with a grid paper. That's all they were doing. So it says approximate the length of the hypotenuse to the nearest tenth using a calculator. So maybe pause and try this one. If it helps, you can count the legs of the triangle here and here on my grid. Might help, but maybe try practicing counting them and then practice finding the length of C, which is always this longer piece. So we count, we should get 1, 2, 3, 4, 5. So this is 5 across. And then I count down 1, 2, 3, 4. Okay, so I'm going to go 5 squared plus 4 squared equals c squared. 25 plus 16 equals c squared. I'm going to take 25 plus 16. Just check it. Okay, I get 41 equals c squared. We square root. And when we round to the nearest tenth, because that's what it says right here, we should have gotten 6 4/10 units about. And that's how you do it. The reason this is also really nice is you don't have to find any missing, like a leg. It's really nice because it's just square, square, add, square root. Okay, there's no like change. All right, so this is a little different. It says Siska wants to find the distance between her house on one side of a lake and the beach on the other side. She marks off a third point forming a right triangle as shown. The distance in the diagrams are measured in meters. So it says that this point is at 1020 and this point is at 280.20. So since we're doing the across left to right, we don't care about these right now because I'm only worried about the distance here. So what we would do to find the distance here is we do 280 take away 10 because I'm trying to find the distance between here, right? So also if I was trying to use the 20s, that would really help because they're the same. So if I do 280 take away 10, we would get 270. So like we could call that our A. And then we're going to do the same thing here. If you notice, the X's aren't going to help me. I'm going to take my 164 and now I'm going to subtract my 20 because again, I'm doing the up and down, which is the Y's, so I only care about the Y's. So if I do 164 take away 20, I get 144. Okay, and maybe we then call that our B. So we need to solve for C. So 270 squared plus 144 squared equals C squared. So definitely want a calculator for this. So this is 72,900 plus 144 squared is 20,736. I'm gonna add my 72,900, C squared. I get 93,636 equals C squared. We then square root, and what's really nice, it does come out as a whole number. And so we would say it's 306 meters, because it says right here that it was measured in meters. So there's our answer. Find the distance between the points 3, 7, and 15, 12. So again, I think your grid is close. Hopefully it copied enough. The first thing we're gonna obviously have to do is graph these points. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Uh-oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I thought I had 15, 13, 14, 15. We're gonna estimate this. Here, put 2 more. This is 13, 14, 15. Okay, we'll just estimate this. Sorry guys, I thought I had enough. So then 1, 2, 3, really, right when I'm counting, it gets stuck. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're way up at the top here. Oh, that's a pain. So the way we would do this, you can draw a right triangle, either or. I'm gonna go this way and then come across this way and come across this way. So what we're trying to figure out is this, right? So we need to find the distance between here and here. We can just count, which is really nice. So this is 1, 2, 1, 2, 3, 4, 5. And then we would count across here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so remember we had to add these 2 little ones here. So we got 12 here. So 12 squared plus 5 squared equals C squared. 144 plus 25 equals C squared. We add these together, 196 equals C squared. We square root, and we actually get perfectly, oh, not 13, C squared, just 13. We get perfectly 13. And so we would say that it's 13 units. And there's our answer. So not much really the things to remember. Maybe the color purple. That'd be a great thing to remember because I want to see if you're listening to me. So write the color purple in the things to remember. Let's see if you're listening to me. And then here's your independent practice. It's very, very similar to the example problem. So go look at the example problem to see how we set this up to help you out. Okay? All right. Adios. Until next time.